In this video segment, payments are included in the financial analysis. The addition of payments adds substantial complexity to equations, and in fact, equations for determining the rate and number of periods are not available or possible. But they add minimal complexity to the spreadsheet functions. This makes spreadsheet functions more attractive, less error-prone, and mandatory for the rate and number of periods. In this segment, we only consider equal periodic payments. Unequal ones will be treated in a later video. If we look at this, we have payments, equal payments over 6 years. We deposit, it comes out of our pocket, so it's a deposit of $500 into account. And then we withdraw 80 in year 1, 80 in year 2, all the way up to 80 in year 6. So we have 6 withdrawals of $80 each. If we wanted to find a future value, it's fairly simple with a function. 5% is our rate. 6 years. Payment is this next argument. Instead of 0 as we did previously, we put in 80 because that's what we're going to withdraw. And then comes the present value, which is a minus 500 in this case. And if you do that, you come up with $125.89. You can do that with cell functions or cell addresses. G1 is the rate. Rate is in G1 right here. The number of periods is in L2. G3 contains payment. Same in all of them, so we could use any of these. And finally, F3 contains the initial deposit that you put into this fund. When you get done, you received your 6 payments of $80, and you can also then receive $125.89 at the end of year 6 in addition to those. Let's look at this if it was $100 that we withdrew each of the 6 years. Use the same equation, only referring to this row 8. You see down here it has 8s in it. And it comes out to a negative $10.14. This is say at the end of 6 years, after withdrawing $100 a year, you will owe $10.14. Essentially, that's interest that was unpaid earlier. This shows the advantage of using the assigns and these functions and to assign conventions. If we're looking at the result, you can see if you're going to receive more or if you're going to have to pay something extra. And that's why they use the sign convention. But that is the future value function with periodic payments. To illustrate this further, let's look at a tabulation. We start with a $500 balance, which I pulled from F3 right here, and I put a negative sign. Typically, you start with a positive balance. Don't have to. I think people do it different ways. They tend to use these columns. Period, withdrawals, interest, and balance. Sometimes you add another column, which is payments and withdrawals both. If you have both, you don't have to put them in separate. You could change the signs. It's clear probably to put both. $80 withdrawal. We earn $25 of interest, so 500 minus the 80 is 420. But then we earn $25 interest, which increases that to $445 interest. This G3 came from up here. $25 interest is that rate G1 times the balance at the end of the previous period, which is F3. Remember that, the end of the previous period. The end of a period is the same as the start of the next period. So over period 1, year 1, we have $500 on account. It has to be in the account for the whole month to earn this interest. But it's the $500 that's earning the interest, and then you end up at the end of that period with $445. If we want to do the rest of these, this is G3. If we just did this, it's not going to work. In other words, drag it down, put the cursor on the bottom, it changes to that small cross. And what did it do? It made this G4, G5, G6. G4 had $80 in it. G5 has nothing. Down here it had 1. It took this column. That's not what we want. So if we put a $sign in front of each one of these, it says don't change the G and don't change the 3, but the $sign tells the spreadsheet. Now we get down here, it changes that small plus, and it stays the same, G3 all the way down. Another way, we could just put in here equal the previous one, G14, which is this number. And then we drag that down, and we'll change it every time, but always does the previous one. This says G15, which is here. This one says G16, which is the previous one, and so forth. Either way works. The interest, G1, we want that to stay constant, so we put $signs in front of it, because that's always in G1. The multiplies times the previous balance, which is going to increment up to a higher column number in each one, so we want that to change, so we'll leave that as is. We can drag that down, and we have the correct interest here, which is 5% of $445, but these are wrong. Why? Because we don't have a balance here. We can get that easy enough. We want all these to change, each one, so we just go down there and drag it down. And there's $125.89 that we had up here. It does the same thing as the future value function, but here we tabulated it. If we wanted to change this $80, which is G3, to the $100 in G8, we can change that one place. And there we are. We have the $10.14. So that illustrates the basic future value function as well as tabulations. Now let's look at computing the present value with payments, equal payments of $50 a year for 6 years. We want, say, a future value of $250 at the end of year 6. And if we make $50 payments, what do we have to deposit up front or receive? Well, it turns out if we make $50 payments and find the present value, 5%, 6 years, we pay in $50, so it's negative, $250 at the end. That we receive $67.23 up front, make $50 payments for 6 years, and to receive also $250 at the end. So we say, gee, we don't need to receive it at the beginning. We want to start depositing, not receive. So let's try $30 payments. If we do $30, doing the same thing. Here's the minus 30, or if you do it here, it's in B14 in this case. And that means you put in $34.28 up front, deposit $30 a year for 6 years, and you will earn, or you have your $250 that your future value, which we put in here, or in B13. And you could play around with that $30, try minus 35 and so forth. If you want to get it down to 0, that gets down to $8.90. Note this one changed because I used cell addresses. This one didn't because I put in the numbers. So let's change that back, and we'll find a payment in just a second. Let's look at it a different way and find the number of periods. That's a little bit different numbers. If we wanted 6% interest, the present value is $1,000, so we're going to put in today out of our pocket. We're going to additionally do that, we're going to deposit $500, and we want a future value of $5,000. How long would it take to do this? How many years of putting in $500 a year, assuming we start with $1,000 we deposited? Well, it's 6.1. How do we determine that? The NPER, N number of periods function. 6% minus 500 is the payment. Then comes the present value minus 1,000, and we want it to become 5,000. Doing this with cell addresses, that uses those numbers right there. Either way, it comes up with the 6.1 years. The numbers of period, very handy. Works well in a couple different applications we'll see. We want to determine a rate. Say a present value, we put in 1,000. We're going to make payments of 500. And we want a future value of 5,000. Do this for 5 years. What rate would we need to have to achieve that? We'll use the rate function. 5 minus 500 is the payment, minus 1,000 up front, the present value, and want to achieve 5,000, receive it at the end. And the interest rate would have to be 12.43% interest. Doing this with cell addresses shows that you use the same cells. For the last part, we're going to look at determining payments. If we had a 6% rate, we deposit $1,000 up front, and we want $5,000 at the end, essentially saving up for some expenditure of $5,000. And 5 years from now, what would we have to make as payments? Well, we put in the 6%, 5 years, minus 1,000 is the present value. We're doing a payment, so this is present value. Future value is 5,000. And you do that, it says we have to make payments of $649.59. Doing this with cell addresses, it refers to those 4 cells, and obviously you get the same answer. So with payments, it's fairly easy. You just put different arguments in for each function, and you get the answer you need. And that takes care of equal payments.